Hello friends, welcome to the Laptex. My name is Nasir, and today we have a very interesting case study. However, today I will not going to disclose the solution to all of you, but this solution is available with my students course. Those who has taken our course, they will get this case study, and if you wish to buy the solution of this particular case, then you can contact us on the given number. But I will give you the clue. It's not that I am not totally disclose this point, but it is very true that most of the time I have told you the solution. You can consider this is the test today. You will write the comment on the comment box. I will give you some clue that how long the signals and the voltages are okay, and few things are missing. What step should be taken? As I have disclosed the logic to all of you, many things I have told. Now you have to write possible answer, whatever you know. You can comment on the YouTube comment box. Now I have a Dell 5000 series, and it comes with i5 11th generation, and the part number is 19861-1. So fortunately the diagram is available only, and unfortunately there is no board view available of this particular model. And the good thing about the Western motherboards that it has written like Q, D and U numbers. However, there is no R and capacitor number, but most of the thing is readable, and whatever we want to find the signal, we take help of these components. It takes time, but we can reach to the solution through this type of the coding and nomenclature which is written on the board. So what is the scenario? Let me show you. So let me inject Dell. So here the DC jack, and you can see the ampere. Now it will turn on by itself. Now 20 volt I have injected, and it turns on. You can see that the light is available, it is turned on, and 104 milliampere is the total load. I'll show you the most of the things which we have been discussing all of the time, but I will hide something. The solution I will hide, because this is included with those guys who has associated with us, and as I have promised to all the guys that if you keep on touch with us, then we will time to time, every time whenever we get such case, very interesting case, I will give you the solution of these things. But let me tell you one thing first, that the logic is almost same in all motherboards. Those who is hankering after like the latest generation, they always tell us that I want to understand about the latest generation. Most of the time I answer to them that what is the difference between the old generation and new generation, like 6th generation, 7th generation, and the new generation like 10th generation and 11th generation and 12th generation. They cannot answer me. RTC is same, charging section is same. However, there is the earlier it was the only buck, now it is buck and boost both. Very few differences between the latest and the old, but at least if you want to know the latest, you need to understand the basic. So RTC is same, RAM section is same, and communication is almost same. Few thing comes like taking care of your thermal sections, your LVDS area is changed, converted to the EDP. Many more things has taken place on the motherboard. Changes has taken place. So but I promise those who has seen our courses video, there I have taught this very thing, what is the new in the uh, new generation, like after onward 10 generation, where the half fever is newly launched, like 3 VR is embedded into the CPU section, and that requires some signals, some voltages, as well as the C concept is the very unique whatever I have taught to all of you. Those who has learned from us, those who has gone through entire 300 videos, there is around more than 25-40 minutes videos of only about the PCH there. And also around 10 to 15 videos of the CPU. I guarantee you, you will laugh when I will tell you that what is the solution behind it. You have gone through those things. I will make up entire video, full video, and I will include you these things in your account. Okay, and those who will join us with the new things, like this is our upcoming offer, which will release in the eve of New Year, Christmas and New Year offer. Here we will include all these case studies. Look, every time when we launch the offer, we try to give some new things, and those who is associated with us for a long time, they will be benefited with this types of offer, because uh, we try to add the case study, new case study, like 10 generation and 11 and 12, whatever will be coming. We will try to keep on adding in their accounts. So if you are trying to improve yourself, as I will tell you, something is missing and you know very well that particular signal, but in new there is something special which you need to understand, then only you can crack these types of problem. And that new things I have already taught in the 300 videos. Along with that 300 videos, we will add like this type of case study in your course. So if you are interested in this 4.0 version, there one more thing is added, like on particularly switching section, like if laptop does not trigger, then how many area you can identify where could be the problem. If laptop is not triggering, you can hit those things. These all are based on the your practical things. Few things are theoretical, but most of the things are practical. This is also going to be launched along with the 4.0. So if you are interested, the number is given. You kindly WhatsApp on this number, because we don't have time to pick up calls. So we request you, all of you, that you just leave the WhatsApp message. As soon as we will get free, we will try to reply you, so you can get advantage of this new upcoming offer to contact us. Now let's come to the point. Now let's back to the story that it's hold on 104, and let's begin from the very beginning. However, we will take few time to find out the things, because as I told you that it has no board view. Let's visit to the WinFX. There we have found only the board, the schematic PDF. Okay, the BIOS is given, and the diagram is given. Okay, so we have right now open here the diagram, and this is the i5 11th generation. Okay, so why I am telling you generation again and again. So we will try to find out मास्टर रुकिएगा एक मिनट, खांसी आ रहा है. So this was all about the offer. If you are interested, you can contact us. Now let's back to the story, and it is sometime white and sometime orange. Okay, few times I have seen that it is the light appears orange also. Okay, it's all right. We will try to find out the how many state it has crossed, how many signals are available, many more thing we will try to find. So let me zoom to the camera. Here is the part number. First of all, this is part number 19861-1, and let me open the heatsink. Okay, let me turn off power. Again and again I'm telling you, we should talk about the generation. Now in some scenario generation has no matter at all, but in some signals generation really matters, because it causes to stop core voltage sometime, no display, many problem comes in the generation. Like C time also could choke no display, or it could choke any voltage. Many types of problem can be created by the C type. So here is the SRK05. As it is written, as I have shown you, that it is written that where I have seen here i5 11th generation. Okay, and Dell Inspiron 5402. This is the it is also called the 5000 series. So now we will turn on and we will try to find the 3.3 and 5 volt scenario first of all. And here is the RAM IC, and this is the new RAM IC which first time I have seen. And you can see here that let me open the RAM module. So the first time I have seen that apart from the LV IC which is used usually on the Lenovo, apart from that this TPS IC, first time I have seen 51486, which has introduced with the VDDQ as well as VPP voltage. The one regulator is regulating both voltage. So this is the first IC I have seen apart from the LV. LV is the multi regulator which generates 2.5 volt as well as VDDQ as well as VTT, as well as it also convert the VS section from the S5. So many thing new, or many new ICs are upcoming, and also it is on the process. So 3.3 and 5 volt, this is the SYIC, the very normal simple. Now let me set my multimeter on voltage mode. Okay, now you will eye on the multimeter what I will check. So let me turn on. Okay, now turned on. What is this? 5 volt. 5 volt is absolutely right, and 3 volt, it's all good. VPP, this is the sequence I'm telling you. However, Western is not giving you this particular motherboard. PDF has no power sequence, but Western sequence you can follow from the Vegas, from the Cedar, any of the Western motherboard you can take as a reference for the power sequence. So if these all are good, then you need to check the power grid also. I'm not checking right now. If power grid is all right, then the further voltage you will get the directly. I'm without wasting your time. So let me check the VPP voltage, 2.5 volt. It's all good. And VDDQ I'm going to check. So here 1 point around 2 volt, which is required, and it is good. This is my hair. I think I am losing my hair. It's not good. It seems it's jumper wire. So here 1.2 volt. So it's good. Now what is the one more thing, let me tell you that I have made a BIOS from the BIOS website, from the Dell website, and I have programmed it. However, I have the backup also, but don't worry, it is 100% sure, because I have made it with the service tag number, and those who has learned from me, they know very well how to build the BIOS from the website and from the old the dump file. Okay, so BIOS is good. Now NVDC or HPB. So battery section 17. This is the hybrid power boost. This is the HPV technology, and the new charging IC. Again, I am seeing no 9538. I have seen many times. Okay, it is used in 7th generation also, 7th, 8th, 9th. So it could be used like NVDC and sometime HPB both. So this particular board has the HPB hybrid power boost, like it is used in the Apple. The PWM is released before using the battery. This is the HPB. And what else? I think this is also one regulator, kind of regulator, 1.8. Few things you need to understand, that the basic requirement of the motherboard is like 3 volt, 5 volt, VPP, 2.5 volt, VDDQ, RAM voltage, and 1.8 volt, 1 volt prime, and 1 volt VCC ST or SA. These we need to get at any cost before generation of core. So one of the most important part, 1.8, we are getting it. And what else? This seems core 95869. I haven't seen it before. This is the new. What is this? The kind of IC. This might be 1 volt regulator. 1 volt prime, 1.05 or 1 volt. So everything is all right. Core, here is the core, no core voltage. That is why you can see the load 11 generation around 600 to 1 ampere, between 900 milliampere or 600 milliampere, in between there must be load. If that would be graphic, then it would increase around 50 milliampere more, like one and a half ampere could be load with graphic. Since there is no graphic, so around 1 ampere I'm expecting. So the ampere is very less. Okay, and what is the scenario of run? Because your core can never work. This is the usual concept I'm telling you. You can say that's universal truth in the laptop repairing, that you cannot expect core voltage without run voltage, or without S0 voltage, or that is also known as the VS voltage. So VS is also required. What is that? Let me check this register. Nothing. So let me turn on any IC this side. No, the 14 pins IC I'm looking for this is the IC. And you know, when your motherboard or when your system uh, enter into the S0 state, there is a few requirements, the state requirements, the ACPI requirements. ACPI requirements is something that which allows system to enter in the S0 state, and S0 state means that your all the power area is good, and then you get the all system power good. And if this happens, then you get the ST standby voltage for processor, ST voltage, and then you get the PCH power. Okay, this is the sequence you can apply in any of the motherboard. There are the many more things, like when the clock run start, and when your ICC clock table starts. There are the many things. As I told you that my entire concept of the PCH communication is around 40 minutes video into around 25 videos. You can calculate around, I don't know, 25 videos of 40 minutes. You will go, then you will understand each and everything. Apart from that, 10 to 15 videos of CPU and 10 to 15 videos of RAM communication, not IC. IC is the department of Dell sir. He tells each and everything, internal logic of this RAM section, 3.3 and 5 volt charging IC, core IC, PCH IC, all types of IC, internal ICs. And what is the good thing about Dildar sir, that the 20 pin 3.3 and 5 volt regulator he has described in 20 videos of 40 minutes. But actually there is the depth. I have also seen that video. I salute him, because depth, he has the depth of electronics. You must go through that, then you will get a boost of confidence. Otherwise, if you tell me to make a video of 3.3 and 5 volt regulator, it will not take more than 1 hour. But he has described the things in 14 hours. There would be difference between him and the normal practical knowledge, depth knowledge of theory. So you must go through that portion, then you will feel really a good confidence in the repairing. Now, run area. This is the run area, which will transfer your 3 volt always into 3 volt VS or S0 state. So 1 number and 2 number pin is the always S5 voltage of 3 volt, and might be vice versa. And the 6th, I think 2, 3, 4, 5, 6, 6 and 7th number is the 3 or 5 volt S5. But you only have to remember this is the S5 voltage, and just opposite to this, look, why I haven't opened diagram yet. These are the common area. Whether someone is giving you the schematic or no, it is not available, doesn't matter. You check with your own experience. That is why experience counts. This type of IC, if has here one pin is given and one pin, that is the clock IC. Usually you will see the clock is giving you the one pin on this area and one pin this area, but without this side pin is the that is the load IC. This is called the load IC. We always say on the WhatsApp to our students, or those who is asking low load case, you just check the load switch. This is the load switch which transfer the S5 voltage into the S0 state. Okay, so here we must get, where it has gone, here we must get some always voltage. So 5 volt, you can see on the screen, 5 volt we are getting on this area. Okay, so let me remove. So 5 volt we are getting on this area, and the same way we will get the 3 volt on this area. But remember one thing, if motherboard is not turned on and 3.3 and 5 volt is suspended state, so you need to turn on to achieve S5 voltage on this area. Like if you have D704P and LAC701P, this type of motherboard, or HP usually motherboard LA compile, you will get suspended voltage. 3.3 and 5 volt would be suspended in that architecture. You will start getting voltage on the this portion after turning on, because it will come out from the suspended state and it will enter into the S5 state, and then it will get some signal to turn on this load switch to transfer this S5 voltage into S0 voltage. This is the concept. Two architecture you have to remember. One is the always, one is the suspended. If it is the always, then as soon as you will enter the voltage, enter the DC jack into the motherboard, you will start getting voltage on this point, and 3 number and 5 number, 3 number and 5 number is the enable area always in any load switch, if it is in the form of IC. Otherwise usually you will see in the old architecture, you will see it looks like a MOSFET. It is the form of MOSFET. It just gives the flexibility of motherboard of load of current, like how much load will transfer. And also one more thing is hidden here, that fan does not require to move as soon as we enter the DC jack into the motherboard, or we give the power to the motherboard. When should fan move? When you turn on the board. When you turn on the board, some communication take place between the IO and PCH, and then your fan is started getting voltage, and then your fan spins. If as soon as you inject the DC jack into the motherboard and the fan started spinning without turning on, the customer will complain you that it is having noise, and you have to eradicate the problem. So in that situation, somebody could have make a jumper wire on this. So you have to remove the jumper and you have to make a switch here like this way. Some required things would come here, usually SLP S3, or in the compile architecture there would be susp hash signal, or susp signal would come here. Okay, now we have 3 volt S5 available and 5 volts S5 available here. This side, do we have? We don't have anything. Do we have S0? No. However, my motherboard is turned on and we are expecting that my voltage must be into the S0 state, but we are not having voltage on the S0 state. Okay, we have described very well in our course that what is the state and how you have to identify, how you can rectify the problems of the states. Many times you will get that your core IC is not functioning because of state problem. There are the various type of state. So we are expecting voltage on the 3 number and 5 number. However, you can see here it is also interconnected. Sometimes two signal comes, and sometimes single signal enable the both circuit. There are the two circuit, 3 volt and 5 volt area. So let's check here. We have 0.300 milli voltage on this area. That is not sufficient. Let's check out what is this, and you might have understood that what should be the voltage on this area. If you are aware, you have been doing repairing job for last 1 or 2 years, you will well understand that what should be the voltage on this area. Now U4005, U4005. So this is the scenario here. One supply is also required. We have been not discussing about the supply, only the scenario that the 5 volt S5 will have the conversion of 5 volt S0, okay, and 3 volt S5 3 volt S5 will turn into the S0, and it requires some voltage. This particular IC requires some VCC supply, and this particular regulator has the VCC which is on the pin number, where pin number somewhere, let me remove it here, 4 number V base, okay. This is the biasing voltage to transfer the voltage. This is also required. Sometimes this is short and it is taken from somewhere else. LDO is taken in the yoga series. I have seen many problems. This is having problem. The LDO voltage comes here and LDO is short from the load switch. Many types of problem could come. That is why the case study could never be same, okay, but this gives you the logic. That is why you watch my video and you like my video and you really appreciate. I whenever go through the comments, I have really no word to all of you. Whatever you write, and it really goes into my heart. So that is why I will inshallah never stop making this video as long as I am alive. So pray for us only. You like it or don't, never matter. You comment or never, really no matter, but you keep on remember us on your prayer. So S3 volt, this is the SLP S3 is required, 3 number and 5 number, and this will turn this voltage into the S0 state. So here we are getting 300 millivolt, and you know very well, if you have been working for a while, you know very well this is the 3.3 volt, around 3 volt, at least 3 volt is required. But instead of 3 volt, we are getting it 300 millivolt. So the scenario is here, we have to find out that where it is coming from. So we know very well that SLP S3 comes out from the PCH. When SLP S4 is already released, then you can have 3.3 volt on the SLP S3. So by checking this motherboard, we can say that our SLP S4 is absolutely fine, because this is the very universal concept that you cannot have RAM voltage, VDDQ voltage without SLP S4. Your SLP S4 is absolutely fine, then only you are getting 1.2 volt on the RAM coil. So my SLP S3 is missing from the PCH. When power button has the debounce logic, then your SLP S4 is released. After SLP S4, SLP S3 need to be released, but we are not having SLP S3 on my motherboard, it seems. Now let's copy it. If you want to check that SLP S4 is released or not, we will find out. So you can see here that these are the points. We are just checking that. So let me reduce it a little bit so that we can see properly. Now SLP S3, all system power good, VDDQ power good. Here I think we have clue here. Yes, this is what we are talking about. This is the clue for you, and my question is to you. It started. First of all, let me go to the this area. We know very well what is this, all system power good, and we know very well this is the SLP S3, and this is power VDDQ power good. Okay, so let's paste it and go to the 1D 2 volt VTT power good. Okay, it's changed, transition has taken place. Now just copy this part and you will enter into the TPS IC, the very IC we were discussing about the first time. I have seen that the dual regulator of TPS, which is introduced with 2.5 volt as well as 1.2 volt. Okay, the first new IC I have seen. However, in the TPS, LV has already available from the 6th generation, 6th and 7th generation. Now, what is the scenario here? This is the logic of the RAM IC. You know very well. Here SLP S4 hash will be high. When you have 3 volt here, then it will release what it will release? Both thing. 2.5 volt, 2.5 volt it will release, and it will release 1.2 volt. Okay, because you know very well it is on the S3 state. If some voltage is on the S3 state, it means SLP S4 is the enable signal. Okay, just behind. So SLP S4 is the working very well because it has released 2.5 volt and 1.2 volt. 1.2 volt, both is okay. Now VTT is the LDO, and VTT has no cont, or there is no reference with the power grid. Okay, so we need to get VTT also in order to work the cache memory of the CPU. CPU will not work if its cache memory is not activated. And one more thing, let me tell you that VTT is always on the S0 state. Whenever you get the VTT voltage, that is always on the S0 state. So VTT control signal, CPU release the VTT control signal, and now you will ask me that that signal will go to CPU to initialize its cache memory, and the VTT control is coming from the CPU. How is that possible? I cannot describe you now. That is why my 15 video of CPU and 25 video of the PCH. That is why. There are the many things is required. It works on the step by step. CPU works on the step by step, not all of a sudden all the signals comes out. Okay, so control comes out from the CPU, then VTT voltage will be established. Here we need to get power good. If two things we have achieved, 1.2 volt and 2.5 volt is achieved, then it tells that all the things PWM is okay, then your power good must be high. Here you can see that I have cut this area. Okay, it is not done as of now, but I will do it now. Where it has gone? Here. So now you pay attention here. Where is the IC? Here. And one more thing that is very important in 51246. If you get this type of IC, how you have to count. Even you don't know how to count this IC. Really, first time I have seen, I got confused. It has taken around 10 minutes to find out that how to count it. It seems 2 pins, but it is considered as a one single pin. This all corner seems pair of the pins, but that is not pair, that is the single. Okay, so these two will count 1 2 3 4 5, and these two 6. Got this point? How to count this IC? Otherwise you will get confused. The best way, if you first time going to see something, then the best way is that you start finding ground. or the VCC area. So you start counting the ground, then you can easily count. Otherwise you will get confused that how to calculate what is the pin numbers. Okay, so 8 number on the diagram, it is giving you the 8 number is power good. So you can have a look here that I have chopped it 1 2 3 4 5 6 7 and 8. This I have chopped it. Why I chopped it? Because I am not getting power good on this area. See here, that was my mistake, but everybody learns by their mistakes. Okay, so I love to make. Now see here, I am getting voltage. Now where is my ground? Sorry. Now you see 2.5 volt, 2.5 volt available and 1.2 available, but instead of that I am not having power good. Both PWM is okay despite I am not having power good. So when I copied it, where I was coming from, I am coming from, sorry, come back where we were coming. So 1D 2 volt VTT power good has become power VDDQ power good. Okay, now copy it and you are going again that area where you are coming from. Okay, this area. Now tell me, why don't I have voltage? It's very interesting logic that the pull up power good has open drain. First of all, power good has open drain. Open drain means that the internal MOSFET of any logic IC is open. It's not shorted to the ground. It's not shorted, you can call it. And open logic has any pull up, you will get voltage there, and the pull up voltage is the S0 voltage. Tell me, all system power good, if you start searching it now, the end of this signal is that there is no concern with this particular power good. Okay, the problem's root cause, we are trying to find what is the root cause. You have to tell this particular area is faulty, and if somebody asks you that how, then you answer to him that this pull up is not available. The simple is that if power good has no pull up voltage, then what is the role of the RAM IC? RAM IC is okay. If there is a pull up voltage, then if it is not available, then we can call it that RAM IC is faulty. But here what we have found, since our SLP S3 is not present, that is why our S0 voltage is not available. Since our S0 voltage is not available, that is why our power good is low. Got this point? But one thing is also associated, and you will tell me that here what is the D, how it will work. Also answer me on the comment box. Many things I have told you. I have been telling you all the solutions. Okay, problem and solutions, both thing. I never hidden anything. Whenever I will hide, I will tell you that today this particular case I am not going to tell you the solution. This is the paid case study for you guys. Those who is my student, this case study will be added to his account. This is my guarantee. Okay, Hindi and English both language. I'll make this video for you guys, those who is my student. And if you are not, if you are interested only particular this case study, you can contact on the given number. Okay, I'm not something that I will cheat you, that I will mislead you. If I have to tell you, I will tell the right thing. Otherwise, I will tell you that I am not going to disclose it. That's it. Now, I'm just giving you the clue so that your strength will also increase, because you know these things very well. But because I have been telling you many things, these are available, these are available, this is not available, how you have to make it. Many times I have told you. Okay, if you haven't seen our video, around 300 videos are there, around I think 100 video of English is at least there. You have to search one by one. And somebody has recommended us that you make a new channel for English. So I don't think that it is possible for us to create a new channel for that. Okay, so this area has absolutely all right. There is no problem at all. Why? Because there is no pull up. Why there is no pull up? Because there is no SLPS3. SLPS3 is the key of this voltage. Since SLPS3 we have checked, it was absent on the load switch area, and when SLPS3 was absent, this voltage cannot be established. Now it is all system power good turn. Copy this. Very interesting case study. Provided that you need to understand few things, like if you are continue now, this is what I have taught to my student. This is the 10 generation processor, and many things I have described there, PLL and many logics. Okay, so various things I have taught them, and if you talk about the PCH, I cannot show you now, sorry for that. So in this PPT, whatever I have shown you, this signal is present there, and this, I think this particular case study first time I'm going to tell, because I haven't seen the problem of this regarding area. The signal I have taught, but there was no case study was present on that time when I taught the theory. But now the theory is available, this one. That is why theory is very much helpful. Now let's copy it to this area and paste it. Now search. There is any possible reason that could choke? Yes, this one could stop this. If anyhow we get this voltage, and if we get this voltage and the ground does not go up, in that situation 3 volt will reach to this area and this become ground. And if this become ground, all system power good will be ground, and if all system power good will be ground, 3 volt will not come here, and also this ground will go this side, and this will also be ground. Since this is ground, so that cannot take place. All the area would be ground. Okay, so we need to check that area. Okay, one more thing, and I don't like this type of SIO, the dual pin SIO. The one is the inside. How can we check this type of SIO? I really hate this type of IO. Microchip MEC1515NB. Only the upside we can check, and even there is the problem of counting that AB like this type of, and easily we can check it when we have board view. Okay, but without board view it's really Herculean task to check this type of SIO. Go away. Now any more area? So this area we need to find your time. For saving your time, I have already searched it. Okay, it's really tough task to search the component. What is that? Q4009 and Q4010, and where it is located? I think here. Now 4009, okay, 4009 and 4010, okay, this two. What I have to find, the last one. What should I expect here? One would be the ground, okay, one would be ground. Here I must get 0 voltage, okay, here I must get 0 voltage. Q4010, when it is turned on. In case if it is not turned on, in that time the high voltage will come here in the off situation, and as soon as it will turn on, the 2.5 volt will be released. 2.5 volt will stop this 3 volt on upside, and 0 volt come here, and this will be off. It must be on, it must be off, okay, very simple. Now Q4010, first of all let's find out which one is the ground, okay. So let me turn off, and let me set it on the beep, okay. It's not very much clear. This is ground, this is connected to this one, and this is independent, okay. So now see where it is connected, okay. Now you have got the clue that this is connected to this one, and here this is the pin we were talking about, that we must not get voltage after turning on. As soon as the 104 milliampere will the load, on that time you should not get voltage on this point. Now I have turned the multimeter on the voltage mode. Let me turn on. The very time I have turned on, you have seen that 3 volt is available, but as soon as you will see the ampere, it is 0. Good, this area has no problem at all, okay. It means that it is working very fine. You have the 0 voltage and it is off. This is on, this one is on, and this is the off. So all system power good is not stopped from here. This is the done good area, okay. So from this area it is good. I'm not telling that all system is power good is the good signal. I'm telling that that particular Q1 is working very fine. Now where else? The die, don't care about this. All system power good, going to be enable for the core IC, okay. Core IC enable, we are enable, core IC enable. So now we need to we need not to check this area, because we know that the supply must be S0 first of all, okay. Then this core IC will work. So what else? So SLP S4 is all right. U174 VCC ST power good, that could be, but I have checked it, voltage level 1, I have checked it, this to remove this one, still the same situation, okay. This area has no problem, okay. And PCH, what? PCH power okay. Later on the number of this area comes, however it is DY, that is not available, so we cannot talk about this one. And this is the IO. The IO is having suspicion, like somebody has heat up. The guy who has sent it to us heated up the SIO. He has removed the S0 area. This is what is done. No BIOS was done. BIOS I have done, okay. In order to make it sure, I have done the BIOS. To keeping the backup, I have reprogrammed the BIOS, but earlier nothing was done except this area, the SIO was tempered, and the run area was tempered. Okay, and that is the very natural phenomena, that if you get this type of problem, and you know very well that you will try to achieve the S0 voltage. Everybody has the good knowledge about the circuit, basic knowledge, but advanced you need to be. Now the scenario is that the 10 generation and 11 generation, the normal sequence will not work. Like this type of problem, as I am telling you, that how many things I am achieving, that could be faulty. But will you replace the IC or not? Write me. So here is the all about the all system power good. Okay, so we have examined all these areas, that all are working fine. Okay, all are working fine. So now you have to tell me that if your SLP, if, let me tell you one more thing, power good scenario is the last. Okay, the first sequence is here. This is the SLP S3, the first sequence. The second is the power good. Okay, the power good is the second, or you can call it the second. This one could be second, or this one could be second, because you know all system power good is associated with the all types of power good. This is the hardware power good, HWPG. HWPG has the every power good, even the RAM. Okay, so both are same. The pull up voltage is will be established after your SLP S3, but your SLP S3 is missing. Then you need to find any, this particular motherboard has no power sequence, so Vegas or Cedar, any of the motherboard you open. This is the Western motherboard. Okay, for your reference, I'm giving you the clue, and take out the power sequence. Here is the timing diagram sequence. Okay, now non deep sleep or deep sleep, whatever, RTC good, as I have found very difficult it was find without board view, as you know very well that you have to check with the multimeter, it's beeping, and then you are going to check that voltage. I have checked VCC, RTC good, RTC reset has good, DSW has good, DS power okay is good, battery low I couldn't check, and after these areas I have skipped many things because I have no board view, I have no clue. Even on the pin, SIO pin, I am unable to check. So lastly, I have seen here, I started seeing here SLP S4 is available, and just after SLP S4 I need to get SLP S3. Any type of Western diagram you will check after resume reset when your motherboard is turned on. So your these area should be okay, as I am expecting, because I have no any help like schematic board view help. So from here my motherboard is okay, then absolutely I should get SLP S4, but this is missing. So this is the sequence of the Western all the time. If I am not getting, then what should I check now? If you want me to this particular diagram, I will send it to you. Okay, it is available on the WinFX, and also that might be free on the many free websites. Very interesting case study you will get, because this is the very common time. First time I am doing it, but nothing physical damage, nobody has worked on the motherboard, but still there is the problem, this type of problem. So I am expecting that this might be the common problem of this type of scenario, this type of motherboard. So how will you repair this type of motherboard? Where will you go? The good thing about this guy who has sent it to me, that he has not baked the CPU. As you can see that it is looking very good. Okay, it's looking very good. The best thing he has done, I really appreciate that he has not done anything. There is no any glue or nothing is seen nearby hitting mark on the nearby CPU. So this is the good thing. If somebody bake up or heat up on the BGA machine, then what does happen, that repairable motherboard is not repaired, because if I repair the logic, then I cannot save the processor, and processor is not available on India, and it's very costly. That is why I avoid to change processor. If it is available on the cheap price, I am ready to buy, as I have announced to entire Indian people that if you have any scrap motherboard with the processor, any generations onward, 6th generation, I'm ready to buy any piece, like 100,000 whatever, I will buy. But unfortunately, the processor onward 6th generation I am not getting. Okay, so that is why I denied to replace the processor here, and a new processor the customer does not approve. That is why we are not having the new processor. Now this is the scenario. Now tell me, what should I check? As I told you that by giving you the reference, that here what can I check, except few things whatever I have shown you, that the RAM logic is okay. Okay, power good is missing, and after power good anything else would take place. All system power good. However, 2.5 volt logic is also good, and we are getting the SLP-S4 but no SLP-S3. Should there be a problem on the SIO, or should there problem be on the CPU or anywhere else? You must comment on the comment box. And if you need this, once again let me show you the, I'll give you if you ask me personally, if you ask me the let me show you once again the motherboard. It's very interesting, many new things you will get to know. 19861-1. okay, 19861-1 Tiger Lake. And I would really wait for your answers, because I have told you many things. Now how do you apply your logic? You must comment on the comment box. You like or not, you comment is very much precious for us. You share it as much as possible, because those guys who cannot afford our course, at least they will get to know many various things, and many important things which will help him to repair the motherboard. So see you guys, and we will meet with the next case study. Thank you guys, thank you for watching this video.